Welcome, my dear students. Myself, Dr. A.Venkatesan, Assistant Professor, Department of Mathematics, St.Joseph College of Arts and Science, Autonomous, Cuddalore. In this video, we are going to learn transportation problem and sequencing problem. So the first problem, to obtain the initial basic feasible solution of the following problem using Vogel's approximation method. The Vogel's approximation method is the best solution given by the optimum one. So now we're going to find IBFS for this problem. So before we start that, we find out the total supply and the total demand. They are equal, only you can continue. That is, it is a balanced transportation problem, then only you can continue. Otherwise, you want to balance the problem. So clearly the total available, the 250 plus 300 plus the 400, the value is equal to the 950. Similarly, the 200 plus 225 plus 275 plus 250 equal to 950. So it is a balanced transportation problem. So therefore, now we are going to find the IBFS. So now we find the IBFS as each and every row we choose the least two numbers and column also. So in the first row, the least two number is 11, 13, 17, 14. The least two number is 11 and 13. So the difference is 2. Similarly, the second row, the difference is 4. The third row, the difference is 3. For the first column, similarly, 11 minus 16, 5. Second column, 5. And third column, 1. Fourth column, 0. So we choose the maximum difference in the minimum value. Choose the maximum difference. So in the maximum difference for the first column and second column, I choose the first column. So in the first column, the least element is 11. So now I allocate the least element for this one is 200, the minimum requirement, and the 250 is availability. So the balance is 50. So the 200 get cancelled. So once again we find the difference for each row and column. So we get the value 1, 4, 3 for the first row and the column is second one. So now we allocate the value, the maximum difference is 5. So the minimum number for the second column is 13. So the available is only 50. So the requirement is 225. So 225 minus 50 is 175. So therefore the second column, first row is eliminated. So remaining 4 and 3 as it is. The second column, once again we are finding the differences. 18 minus 24, 6, 1, 0. So once again the maximum value is 6. Now we allocate the maximum value, minimum number to the second column is 18. So the minimum requirement is 175. So the 775 fully closed and 300 minus 175 is 125. So therefore we allocate the value for this component. So first column vanish, second column vanish, and third column is the difference is once again 1, fourth one is 0, and the first row there is no element, the second one 4 and third one 3. So the maximum is 4. In this maximum we allocate the minimum value 250. So the availability is 125 only. So fully available is given. The 250 minus 125 is 125. So therefore now the first column, first row, second row vanishes and third one is 3. Similarly the first column, second column vanishes. So we can get 13 and 10. So the 13 is the maximum. The minimum element is 275 is demand. So allocate 275 minus 400 is once again you can get 125. So therefore, well, the last one is 10, so once again we can allocate the 125 for the 10. So in this way only you can find the IBFS for Vogel's approximation method. So now we write the IBFS equal to, so therefore the IBFS equal to the initial basic feasible solution equal to, may write 200 into 11 plus 50 into 13 plus 250 into 175 into 18 plus 125 into 10 plus 275 into 13 and 125 into 10 plus, so that's all. So 1, 2, 3, 4, 5, 6 terms are allocated. 1, 2, 3, 4, 5, 6 terms are allocated. So which is equal to 12,075. So which is the initial basic feasible solution for the problem. So if you want to find the optimum one, so once again we go back to the Modi's method. So that is the non-negative terms are greater than 0 once we stop the problem. So now we're going to see the next one is the sequencing problem. So the given problem is 3 machines, 7 jobs. So now first our aim to convert the machine into 2. So how to convert? So first and last machine to find the minimum value. So therefore we first find the minimum of the first machine. Minimum of M1 equal to, so we get 3, and the minimum of M3 equal to 5. So the remaining all the machine you should find the maximum. Suppose 4 machine is there, we find M2 and M3 as a maximum value. Only you should find the minimum for first and last machine alone. So here the maximum of M2 equal to 5. So if you want to convert 2 machine, the maximum value should be less than or equal to the minimum value, or the minimum should be greater than or equal to the maximum. So therefore given problem it is true. So therefore we can convert it into the 2 machine n jobs. So here the minimum of M3 equal to the maximum of M2. So therefore we can convert into 2 machine. So the first one we use GI. GI equal to, we write M1 plus M2, and HI is M2 plus M3. So therefore we frame the value as job A, B, C, D, E, F and G. So we use G. So we add the values 7, 11, 9, 9, 10, 12, 10 and H value is 10, 10, 7, 16, 6, 10, 15. So now we find the sequence of job. The sequence of job is we choose the least number from the above matrix. If the number appeared in the first machine, you could start the job in the left onwards, from left. Suppose it appeared in the second machine, we starts from right. So we have 7 machine, so we choose 7 boxes. So choose the least element is 6, so it is appear in the second machine, therefore I write the job in the from right side. So second minimum is 7, so which is also in the second machine, I can write C here. Another least number is 7, so it is appear in the first machine, I starts from left. So next least number is 9, so it is appeared in the two places C and D. C should not take because already it is allocated, so only you can write D, so we can write D. So the second possibility as 10, there are B, F and G possibility. So the minimum one is B, so in a second machine I can take B, and another one F, also the least one, in the second machine I can take. So the G is a 10, so in a first machine, so I write G. So therefore the sequence of the job is A, D, G, F, B, C, E. So from the sequence, now we are going to find the total elapsed time. So first we write the job sequence. So what job sequences we are finding? A, D, G, F, B, C and E. So the next one we are finding the machines M1, M2, M3. So each machine has in and out. In is the first value. We are starting value is in. So therefore we started at 0. So what is the value for the first machine? A value 3. So therefore we out is 0 plus 3, 3. Once again we start the same place. D is 3. So once again go back to the value. The first machine D value is 4. So therefore 3 plus 4, 7. So once again we take 7. So and G value is 7. So 14. So once again we start 14. F value for the first machine is 8. So 22. So once again we take 22. So first machine for the B is 8. So 30. So once again we take 30. The C value for the first machine is 7. So 37. So we start 37. E for the first machine is 9. So we finish the first machine as 46 hours. Similarly we find M2. So in the M2 also in and out. So the first machine out is the second machine in. So in the second machine the A value is 4. So therefore 3 plus 4, 7. Now I choose this maximum of first machine out, second machine in. So therefore the maximum is 7. So they are equal. So D value for the second machine is 5. So therefore we get 12. So now we compare the maximum of 14, 12. So the maximum is 14. So G value is for the second machine is 3. So 14 plus 3 is 17. The maximum is 22. So F is 4. So 22 plus 4, 26. 26 comma 30, maximum 30. B value is 3. So 33. 33 comma 37, the maximum is 37. So C value is 2. 37 plus 2, 39. So the maximum is 46. So 46 plus 1, 50. Sorry, 46 plus 1, 47. Sorry, 47. So next we find M3, the third machine. So in and out. So the second machine out is third machine in. So third machine A value 6. So 13. So once again we take the maximum is 13. So now we add with the D value. So 11. So 13 plus 11 is 24. So the maximum 24 comma 17 is 24. So next we add with the G. 12. 24 comma 12 is 36. So the maximum is 36. So F value is for third machine is 6. So therefore 42. So the 42 comma 33, the maximum is 42. B value for the third machine is 7. So 49. The maximum is 49. C machine is 5. 49 plus 5, 54. So 54 is the maximum value, and 54 comma the E value is 5. So 59. So the maximum, the total elapsed time for the machine is 59. So the total elapsed time for the given problem is 59.